Now let's review on one architecture of a real processor, SPARC T1. I believe I have mentioned about this processor in last class as well, last lecture as well. Uh, SPARC T1, in terms of, remember about it provides the hardware threading that right, and that's open source processor. We can actually look at their source code on the Verilog level, and there all the documentations are there in the internet. So you can just search and open SPARC T1 and get those specification. So this picture is out of that spec. All right. Uh, so what it this is a multi-core system. All the system you are looking at, this eight SPARC core and L2 caches and all this DRAM controller, etc., etc. All of them are placed in one single chip. Okay, that's truly a system on chip kind of thing. So how it looks like, your APU is floating point processing unit, floating point number processing unit. So you can well imagine this SPARC T1 system is not for scientific computation. Their market is their targeted market is for the web service, where floating point unit computation is not that important. Web service is more about integer processing. So that's why this guy has only provided one single floating point unit, and the main integer processor, the generic processor, is contained like 8 SPARC core, and each of the SPARC core give you, I believe, 8 hardware thread. But that also can be configurable, like there are couple of variants, maybe 4 thread, 8 thread, 16 thread, etc. I think I have hard 64 hardware thread as well. All right, so each SPARC core having 64, let's say at the max 64 hardware threads, and each of these SPARC core has their own local memory, like local data memory and instruction memory, L1 data cache and L1 instruction cache. And then it has like 4 L2 cache memory. They call it a bank, L2 cache bank 0, L2 cache bank 1, L2 cache bank 2, and L2 cache bank 3, L2B3. That's what it represents. So what is this is like each 2 core are connected to one of the bank. So core 01 connected to bank 0, core 2-3 connected to bank 1, core 4-5 connected to 1-2-0-1-2-3 4-5, yeah, 4-5 connected to bank 2, and core 6-7 connected to bank 3. And they are connected through, not through a bus system, but it's called a cache crossbar or CCX system. CCX system is much more like a network switch we deploy for the network communication. That thing is basically your it's kind of, you can think of that network switch you deploy at a home networking or maybe in the college lab. It has a switch, right? It basically route different packet of incoming packet and send it to the target device. Cache crossbar is that's kind of such active switching device there. It's not a passive bus system. So they deploy it, and then each of these L2 cache bank is basically connected to some parallel DRAM controller through some parallel channel 0, 1, 2, 3. They are connected to separate memory, DDR2 memories, etc. And they have some other IO controller system, etc. Not important. But important is this, look at this SPARC core system, multiple core, 8 core, and if let's say 8 core has each of them as 8 hardware thread, then it is basically gives an illusion of 64 processor running in parallel. Okay, so that's the beauty of the SPARC T1 organization. Another thing, beauty is that it's open source, so you can always take a look at the source code, how they implemented this. So that's all for this lecture. If you have any question, please send me an email or ask in the class.